All right, here we go. Unit 9, Lesson 3. We are going to be evaluating trig functions of any angle. So you'll be able to do that. So if we kind of look just at this thing I've got on the notes here, general definitions of a trig function. Again, we kind of have our standard circle equation. Theta is our in standard position, and x and y is the terminal side. So again, thinking about SOHCAHTOA, but again, this is just with x's, y's, and r's. Y over r, x over r, y over x. And then again, cosecant, secant, and cotangent are reciprocals. They're flip-flopped of sine, cosine, and tangent. So if I draw up a problem, let's say we have a circle, looks something like this. We're going to call this right here, let's do blue, call this our equation, or our line. All right, this is the point -4, 3. This is what the angle I'm looking for. This is theta. And then what I'm going to do is I'm going to kind of draw in this right here and create a right triangle. The radius of my circle is going to be called r. So again, this distance is r because it's the radius. So to find r, we're going to use the Pythagorean theorem. So r equals square root x squared plus y squared. R equals -4 squared plus 3 squared. R equals 16 plus 9, 25, therefore r equals 5. And then we can find the following if we wanted to find sine, cosine, tangent. Again, always keep in mind SOHCAHTOA. Sine is y over r. Again, that's our ratio right here, y over r. So again, my y value is 3. My r we just found was 5. Cosine r over y. Cosine is x over y. So that's going to be -4 over 5. And then tangent is y over x, which is -3 over 4. If I was looking for the reciprocals, my other 3, again, I just have to flip what I got. This kind of all relates to the unit circle, where you've got a center of 0, 0, and then you have a radius of 1. The values of sine and cosine are simply the y coordinates and x coordinates, respectively, of the point where the terminal side of theta intersects the unit circle. So if we needed to use the unit circle, again, hopefully this is something you have some prior knowledge from in geometry. I know that my students right now had recently just went over it. So again, if it's brand new for you, that's okay as well. We'll try to go through it. Use the unit circle to evaluate the 6 trig figures of theta of 270. So again, if I draw my circle, 270, every right angle or every x-axis is 90 degrees. So 90, 180, 270 goes all the way down here. And according to my unit circle, we have a radius of 1. So x is 0 and y is -1 here. So I'm going to use, again, kind of the same ideas that we had up here, the special kind of ideas with sine and cosine due to the radius being 1. So we're going to say, all right, well, in this case, when theta equals 270, sine of theta is y over r, which is -1 over 1, which is, again, just -1. Cosine theta is 0 over 1, which is just going to be 0. And then tangent, if you think about tangent, can we ever have a denominator of 0? The answer to that is no. So it is undefined. If we have a denominator of 0, we call it undefined. So again, cosecant as the reciprocal. In this case, it's going to be the same thing. secant, however, again, if I flip 0 and 1, I end up getting 0 on the bottom. So this is going to be undefined because I can't have a denominator of 0. And for cotangent of theta, it is 0 divided by -1, which just equals 0. So it's okay if your 0's in the numerator because that just means, hey, I have nothing. I'm going to break it apart into whatever many groups. I still have nothing. We can also use these things called reference angles, and they help us complete or like form to the terminal side. The relationship between theta and our next theta is shown below for non-quadrilateral angles. So again, in between 90 and 360. So again, we said after I get through this, everything else, 90, 180, 270 to 360. So this is kind of quadrant 2 is my top left quadrant, quadrant 3 is the bottom left, and quadrant 4 is the right half. So we can use these kind of properties to help us find reference angles. So if I have this question, find the reference angle for, excuse me, let's say 5 pi over 3. So the terminal side of theta of 5 pi over 3 lies in quadrant 4. So again, real quick, if I'm thinking about my unit circle, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. I know that 5 pi over 3 is somewhere in quadrant 4. So I'm going to use these properties. So I'm going to say, all right, because I'm in radians, I'm going to use 2 pi minus theta. So 2 pi minus 5 pi over 3 means that I'm going to be left with pi over 3. So my reference angle for 5 pi over 3 is just pi over 3. Now let's do an example in degrees as well. Find the reference angle for theta of -130. So again, -130, if I think about my unit circle, I'm opening up this way. That's actually coterminal. It's actually the same angle as 230, which is going to be about somewhere like that, which is in quadrant 3. So I know that in quadrant 3, I need to use this property, and I say that's theta minus 180. So if I take 230 minus 180, because again, how did I get 230? I followed the rules of -130, but I wanted to use my coterminal point, which if this is 130, then this has to be 230 because there's 360 degrees total. So 230 minus 180 equals 50 degrees. So my reference angle is 50 degrees, which would fill in this section right here. All right, the last kind of idea is evaluating trig functions. So we've got this kind of, I guess, sort of like cheat sheet. It's kind of like a property again, just helping us determine our positives and our negatives for when we are writing our answers out. So if we take an example, let's do 2 examples. Let's say, use reference angles to evaluate functions. Evaluate, my first one is going to be tangent of -240 degrees. So the angle -240. So again, I'm thinking, all right, here's my circle. If I'm going negative, I'm opening up this way. 90, 180, 240 is going to be somewhere about here. And again, if this is my angle for -240, then I know that opening up this way is going to be 120, because 120 plus 240 equals 360. So it's coterminal with 120. And because it's in quadrant 2, I'm going to use my property for quadrant 2, which says 180 minus theta. So 180 minus theta, we just said that theta equals 120. So 180 minus 120 is 60. So if we think about that, then let's say the tangent function is negative in quadrant 2. That's what we determined right here. The tangent function is negative in quadrant 2. So we can write that tangent of negative 240 degrees is equal to negative tangent 60 degrees, which if I think about how my unit circle works, okay, so again, I'd have 30 degrees, 45 degrees, 60 degrees. I'm going to have my x is going to be square root 3 over 2. My y is going to be 1/2. My x's are negative. So again, square root 3 over 2 divided by 1/2. When you have fractions, you keep, change, and flip. This cancels out, so we get an answer of negative square root of 3. So there's a lot of work that goes into these problems. Again, you have to remember how the unit circle works. You can use a cheat sheet if you need to use a printout of the unit circle to remind yourself. I recommend filling it in yourself. It helps you kind of learn it and remember it.